exponent rules. First, let's look at adding and subtracting monomials. If we look over here, we have 9x squared y minus 10x squared y. Those are both like terms because I see x squared times y, and over here I have x to the second power times y. So because they're like terms, they're both x squared y, we can add or subtract the values in front. So we know that this is 9 of the x squared y's, and I have negative 10 of the x squared y's, so that equals negative 1 of the x squared y's. Subtract 6w from 8w, so they're saying start with 8w and take away 6w. Those are like terms, so you would have 2w. Let's look at the next rule, the product rule. So the product rule says when you're multiplying and you have like base, you can add the powers, right? So we would have x, same base, raised to the a power plus the b power. If we look over here, it shows us that we have h to the second times h to the sixth. So we have the same base, and it's a product, so we're allowed to write base h one time and add the powers. So 2 plus 6, so we have h to the 8th power. This is really saying I have h times h, right? H squared means h times h to the 6th means I have h times h times h times h times h times h. And in total, there are 8 h's, right? I could write h 8 times. So h to the 8th power is our answer. For this next one, there's no plus or minus in between terms. So some people are tempted to start to distribute, so to speak, that negative 2 to the 7 and say cube. No. In this parentheses, that's one term, one term. So we're going to multiply the numbers negative 2 and 7, and we get negative 14. Using our product rule, we see our a's, a squared times a cubed. I can write that base a one time, and I add the powers. So 2 plus 3. So we have 2 plus 3. And then we see same base b. Now be careful, the exponent is 1, right? I have 1b, b to the first. So then we're going to write base b, and it's to the power 1 plus 1. So our final answer will be negative 14, a to the 5th, 2 plus 3, and b to the 2nd. That's our answer. Zoom out for a sec. So now let's look at the power rule. If you have x to the a raised to the b power, you multiply a times b. So you'd have x raised to the ab. If we zoom in here, we would have x to the second times 3. So that's x to the 6th. And if you expand this, you can see that if the outer power says 3, you multiply x squared times itself 3 times, right? And then if you expand those x squareds, you would have 2 x's, 2 more x's, and 2 more x's, and x times x times x times x times x times x is x to the 6th power. So if it helps you to expand, go for it. So for this next one, I see a power 2. So that means I can write that parenthesis expression 2 times. Okay, so now we're going to multiply negative 2 times negative 2. We're not distributing. There's not plus or minus between terms. So we have 4. Now I'm going to scan for all the m's. So base m, base m, base m. So the product rule, I'll write m one time, and I'm going to add the powers. So 5 plus 5 plus 3. 5 plus 5 plus 3. So we'll have 4 times m raised to the 13th power. And that's our final answer. If we look at this next one, we're talking about the quotient rule. So division. So when you have same base, you're going to subtract the powers. So base top power a minus the bottom. Let's look at number 1 for the quotient rule. So 27 and 42, we want to ask ourselves first, what are the top and the bottom both divisible by? So we can play around with it, and we could first try to divide them both by 3. So if I divide the top and bottom by 3, 27 divided by 3 is 9. 42 divided by 3 is 14. So over here I'm going to write on top a 9 and a bottom a 14. Now I have x to the 5th over x to the 1st. So I'm going to come over here for a sec. If I have x to the 5th over x, you can put a 1 as the power of the x in the denominator, right? So the quotient rule says I can write the x one time, and I do top power, which is a 5, minus the bottom power, which is 5 to the 4th. Or in this case, x to the 4th, right? X to the 4th. So we would write x to the 4th over here, and that would be our answer. Now for some of you, it might be easier to look at it this way. Okay, we know that the fraction 9 over 14 is there, right? For a lot of people, it's easier to expand. So on top, if it says x to the 5th, we know we have 1, 2, 3, 4, 5 x's. In the denominator, if we have 1x, you can cross off 1x in the numerator and denominator, and I'm left with on top 1, 2, 3, 4 x's. So it's x to the 4th. It's not 4x. X raised to the 4th is different. It's not 4x, it's x to the 4. Let's look at the next one. So first let's simplify on top. On top we have y to the 2nd written 2 times. So y squared times y squared is equal to y to the, we add the powers, 2 plus 2 is 4, over y to the 4th. So if we have common base, we take top exponent minus bottom, which is y to the 0 power. And this becomes 1. And y to the 0 is 1 because y to the 4th over y to the 4th is the same thing over itself, right? So it's 1. If it helps you to start to expand stuff, go for it as well. Now let's look at the negative exponent rule. So for the negative exponent rule, x to the negative a is the same as 1 over x to the a power. Now it's an exponent rule. So let's look at this one. Negative 5x to the negative 2nd. So it's a power rule. It's an exponent rule. So only the negative power will impact this problem right now. So we have negative 5 times x to the negative 2nd. So 1 over x to the positive 2nd. I can put the negative 5 over a 1. So on top we have negative 5 times 1, or negative 5 x squared. If I had, let's say I had 1 over x to the negative 3rd, it shifts up, and you'd have x to the positive 3rd on top over 1, which would be x to the 3rd. So basically, if you have a term with a negative exponent, if it's on top of a fraction, you can always make a fraction by putting a line under it. Then that value goes to the bottom, like that x goes to the bottom. If it's in the denominator, then it goes to the top, and you change the exponent to positive. So for this next one, 4 and 8. Both 4 and 8 are both divisible by 4, so we get 1/2. Now, here, I know I have base k, so you leave it on top, top exponent minus the bottom. So we'd have 1/2 k to the negative 3rd. Whenever you have a negative exponent, you move that base, so we're going to move the k to the denominator. So we'll have 1 over 2k to the positive third. Okay, so then the 0 power rule. X to the 0 is, x to the 0 is 1. And we actually looked at a problem above where it said, for example, y to the 4th over y to the 4th, which became y to the 0, 4 minus 4, which was 1. Because if you have y to the 4th, for example, and you have 4 y's over y to the 4th, and use your quotient rule, y to the 4 minus 4 is y to 0, you say it's 1 because all of these over all of these that cancel. So on top it would become 1, on bottom it's 1, and your answer would be 1. So x to the 0, base to the 0 power is always 1. 7 times x to the 0. So only the base x is attached to the 0 power. So it's going to be 7 times x to the 0. That becomes a 1. So 7 times 1 is 7. And last one. So on top we see y to the 4th raised to the 2nd power. So I'm going to write y to the 4th 2 times, or what I'm saying, w. So on top, using our product rule, we have base w, we can add our powers. So 4 plus 4 is 8. Using our quotient rule, we do base w, top, minus bottom, which is w to the 0 power, which is 1.